Hi, if you don't know me already, my name is Zephaniah Flynn. I'm a senior application engineer at Metadata and a lead engineer at Zolved. That just means I'm the only engineer at Zolved. And I'm here to talk to you about the necessity of refined types and how you can apply it to your applications. Yeah, and plus, please forgive me. This is my first public technical talk, so if I do trip over myself, please forgive me. So, what are we trying to achieve when implementing refined types into our Scala applications? We're trying to ensure that invalid data is unrepresentable within the boundaries of our applications, making our apps less perceptible and preventing unpredictable errors that could otherwise be prevented. However, to understand this and achieve this goal, we have to first understand what refined types are. So, refined types are a way of expressing constraints at a type level with capabilities at compilation time and refined time at runtime and refining primitive data types. So let's dive straight into an example. So here we can see that we have a case class person. As you know, a person needs a name, an age, and an email address. You can see that it has primitive types, a string, an integer, and another string. But the problem with this is that, when creating or instantiating a person, this makes us with these, primitive unrefined types. This opens our applications to any possible literal, with the possibility, as also as a software engineer, we need to cater towards the massive range of values that a user can input into our application. So what refined types aims to do is stop all of this jargon from breaking the boundaries of our application. And if you were to do this traditionally, it would look like the following. So here we have a basic application. It takes a name, an age, and with this application, say the age requirement is 18 years of age, and it also takes an email address. So it passes these user inputs into the method validate traditionally. I try to jazz up with a cool little name, so mind the naming. So as usual, we don't want our names to be non-empty, and we just validate this with which will return a boolean. Non-empty, we just validate that it has a non-empty string. And also, as the requirement for the application, the person needs to be more than or equal to the age of 18. And also, we have to make sure that the email inputted matches our email regex defined above. So traditionally, you would pass this to an if statement, check if they all return true. And then if this is successful, we will instantiate a person and return a person. And if it fails validation, we'll have to, return an error and raise an error. Yes, so, this example that I've shown, it's not quite reliable. This validation, how do you know that this validation is going to be used throughout the application? So imagine another engineer comes up to this project and a new endpoint is created. How do we guarantee that this validation will happen in other parts of the application? Maybe there's a new endpoint or a new API or a new Kafka topic that takes a creation process event and persists this data into a database with error-prone data. Furthermore, when testing existing functionality, us as humans, as engineers, I'm sure you've done it before, are prone to mistakes, and this could lead to invalid test data and invalid tests, which we can't rely on and reduces our confidence in our applications. So, how can we mitigate against these things that I've just mentioned? So this is where the necessity of refined types come in, which guards our applications from invalid literals. So let's take the example of the case class person that we mentioned earlier. So So as before, we want to make sure that the name is non-empty. We can see that it has a primitive type that we want to refine, and we want to make sure that this type or any literal defined is non-empty, and we're bringing this constraint to the type level. So type level. So we have to make sure that there are no non-empty strings. So let me let's do a quick demo, a simplified demo of a refined type. As we saw before, that we see that it's not appearing on the screen. I need to cross it over. There we go. Otherwise, it'll be useless if I was just having a demo of the code and you can't see it. Oh, let me try and zoom in. Can you see that, guys? Yes. Cool. Cool. So as you can see, we've defined the type name, our refined type, and then again that we have the primitive type string, and we're refining it to make sure that this string or any value assigned to this type is non-empty. So here, if I uncomment this, so here we've taken advantage of the auto macros. So there's an implicit macro turning into a unrefined literal into our type refined type according to the signature. So if I try to compile this, it disallows us from instantiating a non-empty string. So as I said before, this guards against any human mistakes. So say we're testing our application or we're using any static data within our application, it guards against any mistakes and brings the constraint of a non-empty string to the type level. So it's impossible to even define a non-empty string within the application. So later on when we're trying to debug, we already know that there are no non-empty strings and all constraints and all validations have been met. Cool. So, this covers a compile time example. So, when we work with literals at compile time, and that we've all covered that. But, what happens when we work with refined types at a runtime level? And we will cover this now, hopefully. Cool. So we have exactly the same application here. So we've taken a user input of name. Oh, so let me zoom in. Sorry. All good. Nice, nice. So again, we're expecting a name from the user, an age, a minimum age of 18, and also an email address. And then this time we will pass it to a method that accepts the primitive types string, int, and string. And these are unrefined primitive types. So refine v is a nice little macro that we can explicitly instantiate, and this will check that our unrefined literal meets the conditions of the type system or the conditions declared at the type level. So refine v checks whether or not that the unrefined literal meets our conditions. So on the left, if you're familiar with ethers, on the left it means that it's failed the conditions of the system, and on the right means that it successfully refined the literal into our type that we instantiated earlier. So here we can see that we now have name, age, and email. So this comes with, so timepit comes with out of the box with a lot of common conditions that we might need within an application. For example, as we defined earlier, traditionally, the age needs to be equal to or greater than 18 years of age. So here we've defined greater than equal, and we've refined this primitive type int. So any integer that enters the application needs to be 18 or over. And then we've done the same for a matrix regex. So there's loads of conditions that you can just use right out of the box. So you can define your regex directly with the type. I think with Scala 2.11 or 2.12, it doesn't accept literals, or it doesn't work with primitive type literals. So you have to define it with, I think, shapeless type library. But I can go into that later. So again, so now we've done refine V and ensured that these conditions have been met at runtime. So these are dynamic inputs that at compile time that the software or the application does not have any knowledge about. So if we come down to here, we have validated our inputs. So we just use validated next so we can collect the possible errors and the failed errors from our ethers. And then once they're successful, we just map into it, and we then instantiate a person refined. So when we've instantiated this person refined version of the person that we did earlier, when looking at this case class, and no matter where we use it within that application, we know that the name, age, and email meets the conditions of our application. So it helps maintain maintainability. So as a software engineer, don't have to go back and make sure that these validations have been met, write extra tests that become very boilerplate, and it just wastes a lot of software development time. And I'll give a quick demo. So here we just have an io.pure, and it returns a person, and if it's invalid, we just raise an IO exception. So let me get my terminal up. So SBT. Oh gosh, I forgot to remove that comment. I did this earlier as well. Oopsie. There we go. Just wait for SBT. Cool. So let's run a second main. So let's give me a number. If anyone, just throw out a number. 45. Cool. Let's put 45 in. That meets that meets the conditions. Someone's email address. I might message you later. I'm joking. Oh my gosh, I didn't enter a name. We can actually use that. Yeah. So bob@gmail.com. Nice. So here we got a failure. Obviously here, I don't know, we didn't put a name, and we supplied a non-empty string. Oh yes. I don't know why. It's like I'm doing the demo for myself. There we go. That's really good. So nice. So here we provided an application with a non-empty string. So we see that the predicate is empty failed, and so this invalid literal didn't break the boundaries of our application. So let's maybe put some more errors in here. I know, ignore the really bad errors. The error messages are good. It tells you exactly where things are going wrong, but the wording of it is a bit iffy. I might raise a PR for that, actually. Let's do two. One is the unrefined one. We could do that later if you want. Okay, so let's do 13. This will be a very smart 13-year-old. A terrible email. I don't know why I keep doing the name blank again, but okay, anyway. So, because we used the validate from Cat's core, we can see the list of failed conditions that our application requires. So, see here we've supplied an empty string, and the 13 does not meet the age requirement of this application, and also that email does not match the regex at all. So let's just do this one more time and get a successful two. Oh, I keep doing that. Why do I keep doing that? Nerves. Two. Oh my god! Why again? You know, again. One more time. One more time. Yeah, I should. I should. You know. Cool. Cool. Okay. No, yeah. Age. Well, what is my age? Forgotten already. 29. My email address. I'm not gonna give it to you. You can ask me that after. That's the Gmail at gmail.com. Cool. All valid. Nice. And yay, we got there in the end. So now that we have the name, Zephaniah, age, and email, and normally, obviously, you would persist this to a database, and then when you're doing debug and everything, we already know that this data is valid, and it's impossible to get any invalid literals to break the boundaries of application, which is the whole point of refined types. So let's go back. Okay. Cool. Let's have a quick deep dive into the extra capabilities of the Find library. So as I said before, there's a lot of out-of-the-box constraints that you can apply to your application. So things like making sure that the IPv4 address is correct. You make sure your URLs are valid. Also applying UUIDs with your application. I know there's a Java UUID library, but obviously this only happens at runtime. So if you fail to supply a valid UID, this brings it to the type level. So you can't even instantiate an invalid UID into your application. And then again, valid long. We can have a quick look at the different availabilities. So there's different. Oh no, not that one. Let's go into, for example, the strings library. So, URLs, UIDs, make sure it's a valid short, valid int. So even if you, for example, as you saw before, I took the user input as a string, and I needed an age, which should be an integer. You can use the refined library to even make sure that's a valid integer before processing it in the application. And a bunch of other prerequisites as well. And the same for integers. There's a bunch of nice stuff in there as well. Just greater, not equal to, modulo, and so on and so forth. So that's that. Another concern as well is obviously working with JSON. So working with JSON, the application doesn't know how to serialize and deserialize JSON code. So how do we do that? Oh, nice. I'll save that question. I will definitely answer that in a bit. Cool. Find types in JSON. So obviously we need to deal with, as I mentioned, serialization and deserialization. So obviously working with JSON is an issue, and there are a lot of libraries that are available that cater for this use case. So here's a quick list of the available JSON libraries. If you're using Spray JSON, there's a Spray JSON library for refined types to convert a refined type into a into a JSON object. And also, if you're using Play, there are two different libraries for that. Obviously, you don't see Circ on this list. There is a module called refined-JSON path within the find library. So I assume because refined and Circ are in the same type level ecosystem, I assume that's why the module is supplied within a refined library. So there are definitely capabilities. If you're working with Circ, you can convert your ASTs and so on into a JSON object that your ecosystem needs. Cool. So what have we learned here today? How can we summarize why we need to use refined types? So we have now guarded against any unwanted data from breaching the rules of our application. This in turn gives us more confidence in our applications, knowing it's more resilient and less prone to out of scope variables and doesn't meet the needs of our use cases. Lastly, our application will be even easier to maintain as we don't have to handle, boilerplate validations and future bug fixes. Also, we flag possible areas earlier in the software lifecycle, improving development lifecycle times. So imagine getting all the way to validation or production and then realizing that you have data or static data within your code that doesn't meet the needs of your use case. So, using refined types, it will stop this on compile time. So even if before your code even sees GitHub, you've already found errors in your code. So plus in a way, the application kind of tests itself, as I mentioned, because you can't even instantiate any invalid literals. So I think that's all the time we have, and I've run out of content. So I hope you've enjoyed the talks on the refined timepit library. Are there any questions? Thank you. Cool. And then you had one earlier. Yeah, yeah. Well, it depends if there's a library available that translates, XML objects into a refined type. But I don't think that there are that capability at the time. I haven't seen any XML libraries, to be honest. But I'm sure. But yeah, basically, I don't think so, and I don't know, to be honest. But yeah, but most of the time, yeah. Because I know a lot of traditional systems used to use XML, but a lot of modern systems will predominantly use JSON. So yeah, sorry. Oh yes, actually yes, that's true. Because obviously your database integration, obviously you have maybe unrefined literals from your database, and need to translate that into your application. So there are different tools for converting those types, but they are unsafe as well because there's no guarantee that the data in your database meets the needs of your application. Because obviously, if you're a tester or if someone directly inputs data into your database, it might not meet the conditions of your API or of your application. So there are tools and macros that you can use for unsafe processing, but they are very unsafe as well. So I know Doobie is more of the on the type level. So yeah, basically. I don't know if I made the question. I go babbling on. So, what was your question again? Mm-hmm. Oh yeah. So all of that, yeah. You don't have to manually write those translators, basically. So there's our refined operations that turn those, unrefined primitive types, that data types. So for example, if you're storing I don't know, big int or an integer or a string into your database, there are tools and operations that you can use to turn them into a refined type. But at the same time, there's no guarantee that the data in your database meets the conditions. Yeah, exactly. Yeah, don't have to do any of that. Yeah, exactly. Because it's all a part of the type level system, ecosystem. So yeah, it all works with that. Mm. Mm-hmm.
a scenario where you might decide to keep it less narrow for the sake of foreseeing future changes. And given there are many integration usually,
Mm.
and some of the checks are actually duplicated over different layers.
Mm.
Sometimes it might be considering the complexity of the task, useful to reduce the use of this kind of checks.
Okay.
Because if they done compile time, then it's all fair, right? But if it's done like runtime, then you have a new regex
Mm.
check, maybe. But I'm not sure.
Yeah.
So
First of all, you'll have to define the open and close principle for me. I could partially answer your question. In a way, it's more of a, I don't know, kind of a physical climate because it depends on the expectations that, or the possible expectations that you expect your application to deal with. So you're saying if everything passes at compile time and you want to make your refined types less narrow, it also depends on the constraints that define within your application. So if you had, something like as the age example, defining something, greater than 18, it kind of depends on. It's more of a non-technical answer as well.
yeah,
Yeah, exactly. So it again, it depends on.
because if you think about it, there are people actually at the opposite side
Mm.
where they actually don't make any crossplay like dynamically type people.
Yeah,
So
exactly.
you see, I mean, they might have a good reason to be on the other side.
Oh, so outside of the boundaries of the constraint in the first place.
The number of parts generally defaults to JDBC or the JVM anyway. Okay, so the question the question is whether they have a choice of which database resources you want to use. Okay, the high variety of object relation mapping is very secure. I don't want to go into details of it. Okay, or JDBC connection pooling to your backend systems. It's very secure, very validated. Okay,
You mean in that case, maybe it's not really worth it. I mean,
Mm.
check.
you don't have to reinvent the wheel.
Yeah, because obviously, if you defined your application to, work in a certain way, you shouldn't have the capability of people defining things outside the scope of your application in the first place. So really, you have to look at why you're using refined types in the first place. Because if your goal is to prevent that kind of invalid data inside of your application, that's the whole kind of purpose there. And they want to do that. Maybe you have a different API that kind of deals with those kind of edge cases and not even have to deal with that in the first place. So yeah, cool. I hope I answered that as best as I possibly could.